students. In last class we had seen decoding techniques of memory interfacing. To solve the problem of memory interfacing, I am reviewing of memory interfacing. When we interface memory chip with 8085, actually data transfer from 8085 to the memory and memory to the 8085. What is memory chip? Memory chip is nothing but the group of registers. Suppose 1 kilobyte of a memory chip is there, means 1024 memory locations are there, and when it is byte means a register is of 8 bit. Now to interface memory chip with 8085, I needed address line to address register or to address memory locations. Thus, I am connecting address lines of 8085 to this memory chip, which is unidirectional. Next, data lines of 8085 are connected to the data lines of memory chip to transfer data. This is bidirectional. Data transferred from memory to 8085 or from 8085 to memory. Apart from this, control signals are also connected to the memory chip. Which control signals I needed here? I/O M bar, that is whether I/O operation or memory operation. I/O M bar signal is there. Whether read operation or write operation, read and write bar signal is there. Now, the memory chip has three signals or three pins, which are that the chip select, another is the output enable and write enable. To select chip, the active low signal is to be provided to this memory chip. To read the data from memory, OE bar, again active low, is provided to this OE bar, and to write operation, the write enable signal, which is again active low, is provided to this memory chip. This is the basic diagram of memory interfacing, or what actually the memory interfacing is. Now, to solve the problem or to interface the memory chip given in a statement, for that purpose I needed various steps to follow. Which are that steps and how to solve problem statement is the next topic. The one problem statement is given to you, that is interface 1024 k bytes of memory to an 8085 system with memory map from 3000H to 33FFH. Use 2114 memory chips and decoder 3:8 decoder. To solve this problem, first look over this problem. I need to interface 1024K bytes of memory to microprocessor. For that purpose, in a statement, they given us 2114 memory IC, which is 1024 4-byte memory chip. This is 1024 4-bit memory chip and this is 8-bit memory chip. 1024 bytes means it has a 1024 addresses or memory locations or registers where in a register I can store 8-bit data. And this is memory chip given to us which has a 1024 memory locations, but in a memory location I can store only 4-bit data. My requirement is 8-bit data and the 4-bit data is given to us. Now to make this 8-bit data I needed 2 memory chips. Parallelly I am interfacing 2 memory chips, that is 1024 by 4 1024 by 4. When I am parallelly connected these two, I will get 1024, that is 1K memory locations with 8-bit data, or I can store 8-bit data at a time. And to solve this problem, I need decoder, microprocessor and 2114 memory chips. Now for solution, first I need to find how many address lines I required to interface 1K memory. For that, I am using formula here. 2n is equal to n, where small n is the address lines, how many address lines are there, and capital N is the how much is the memory capacity or how much memory we interfaced. I am putting here 2 to the power n is equal to 1k 1024 bits. Now 2 to the power 10 is nothing but the 1024, means I needed 10 address lines to interface 1k memory. A0 to A9 10 address lines I required here. This is first step to find how many address lines required. Second step is there where I am trying to find memory map. In memory map, the given data to me in problem statement is 3000 to 33FH memory. Put this, how many address lines we have, that is A0 to A15, 16 address lines are there. Out of these A0 to A9 lines are used, 10 address lines are used for memory interfacing and remaining address lines for decoding purpose. Now The addresses are here. 3000 is given in a statement. Memory map 3000 is given in a statement. Therefore, simply I am putting binary equivalent of this 3000. I will get it as a 0011 and all zeros. That is 3000H. Now, all A0 to A9 lines are 00 for starting address and ending address is all A0 to A9 lines are 1. Remaining lines are same as it is. This is nothing but the 33FFH. This is the memory map. Means what the status of each address lines I am going to find in this memory map. Now third is there. I should know IC, that is 2114 IC 2114 memory IC, which is 1024 by 4, means 1K memory locations, and in a location 4 bit can be stored. Pin diagram of this IC is, to address this 1024 location, A0 to A9 10 address lines are there. To transfer data from or to 4 data lines are available, D0 to D3. Apart from this, 2 signals chip select to select this chip and write bar signal is there. When this signal is active low, I can write into the memory, and when this signal is high, I can read from this memory. I explained you in previous case, to interface 1K byte of memory, I needed 2 1K 4-bit memory. This is 1024 by 4. This 1024 by 4. When I am parallelly connecting these two ICs, I will get 1024 memory locations with 8-bit data. Now, how actually I am going to interface this is the next step. This is 13:8 decoder, and these two 114 ICs are available. I am connecting these ICs parallelly. That's why commonly A0 to A9 address lines are taken outside. Commonly the CS bar and write enable bar are taken outside, and these data lines or input output lines, take it sequentially. For first the data D0 to D3, and for second IC data lines D4 to D7. In this way I will have 8 data lines here. These A0 to A9 address lines are connected to the A0 to A9 address lines of processor. Or 8085 processor. The remaining lines that is remaining lines A0 to A9. I am connecting this to the memory chip. From A10 to A15 lines are used for decoding purpose, where A10, A11, A12 this used as the input of this decoder. A13, A14, A15 used as the control signal of this decoder. Now, as per memory map, when A10, A11, A12 is 100, that is 100, then fourth output line of a decoder get activated, and this commonly connected to the chip select of both ICs, that is 2114 and 2114. This both chip has been selected, and for whether read operation or write operation, commonly I am connecting write enable signals to this MEMW bar or memory read or write signal. Now, where is the processor? Here, this is processor. All address lines A0 to A15 address lines are of processor are connected respectively to this decoder lines as well as the memory chip lines. Data lines of this processor connected to the data lines of this memory chip, and this control signal or chip